Yeah, so this is a recording of some solutions to the quiz2 study guide. A few people wanted me to kind of post these. You'll also notice that the audio is a little bit better on this because I have a new headset for these videos. So let me just go through a couple of these, and then you should be able to work through the rest of the problems with no issues. So we're going to start with number 2 on that set. This was for glutamic acid C5H9NO4. And the first question was, just like we've been doing before, you want to compute the number of hydrogen atoms in a 1 molar half-liter solution of glutamic acid. So just to start off, we're going to ignore the hydrogens associated with water in this, so we're just referring to the hydrogens associated with the glutamic acid. You could calculate it for approximately 50 molar hydrogens, but we'll save that for from water, but we'll save that for a later date. So let's just start. We'll just call this problem A, 1 molar 0.5 liter solution glutamic acid. So this tells you the concentration of this entire molecule of glutamic acid in a in your half-liter container. And so just like before, the main thing that you want to do is just remember that this big M is the molar concentration, which means moles per liter. So that means if I had a 1 liter solution of this, it would have exactly 1 mole in it if it's 1 molar. Okay. If I have a half liter, then it's going to have half of that. So your answer for glutamic acid is 0.5 moles of glutamic acid. And we can either go ahead and solve for moles of hydrogen that way, so we just multiply by 9, which would be 4.5 moles of hydrogen associated with that glutamic acid. And then, of course, you can take that further. In most of the questions, you want to take that from 4.5 moles to number of atoms. And so you would just say 4.5 moles times 6 times 10 to the 23rd. And that's the Avogadro's number, and that, again, is things or atoms per mole. Okay, and this was number of moles. And so then you can just run this calculation. So that's it. Okay. The second one, we're going to call that B. You're going to compute the number of hydrogen atoms in a 2 molar 4 liter solution. So again, 2M solution and 4 liters. Same deal, glutamic acid. And so what you do is just take, this is moles per liter, so 2 moles per liter, multiply that by 4 liters, and that is 8 moles of glutamic acid. And now we need to multiply that by the number of hydrogen atoms in each glutamic acid, which is 9. And then we can multiply that by Avogadro's number to get the number of atoms, which is 6 times 10 to the 23rd. And that's the answer. So in general on the quiz, I won't give any numbers this big that would require you to really think about the calculation. It will generally be smaller numbers, but that's the gist of it. Again, no calculators required. And then you can repeat the same calculations for the other atoms of glutamic acid. And what you basically do is you look at carbon. If you want to do carbon, say in part B, it's 2 moles per liter times 4 liters of glutamic acid. So this is glutamic acid, and you know that for every glutamic acid, you have 5 carbons. So you just multiply that by 5 instead of 9 here. Okay. So then we have 40 times 6 times 10 to the 23rd carbons. And if you want to solve it for oxygens, you do the same thing. Again, just oxygen associated with glutamic acid, you would say 8 moles of glutamic acid, and for every mole of that, you have 4 oxygens. So 8 times 4 times 6 times 10 to the 23rd. And that's it.